Alright, so here we are working with what I call tricky vectors. Those are non-perpendicular vectors. Now, so let's look at our example. Bob walks 5 meters at 36.9 degrees north of east. Then he turns and walks at 6.34 degrees north of east for another 9.055 meters. What's his overall displacement? So the first thing to identify is just what are we asking? But when I say his overall displacement, I mean the vector represented by this red line from start to finish. When you first look at it, it's kind of an ugly triangle. What we want to do, move that out of the way, every time we have a problem like this, we want to take each vector that is not already on a nice axis. We want to take that vector and break it into a convenient x and y. And then take another one. Take the other one, break it into a nice convenient x and y. Now we're going to call these x1 and y1, x2 and y2. Because if our goal is to get the red vector, remember that we can move our vectors around. Now, look at the red and blue triangle. Now you got a nice right triangle you can work with known values on the x-axis, known values on the y-axis. So we can do this. Let's get this out of the way because it kind of clouds our vision. So, if our goal is to find these blue vectors, we need to get some specifics for the problem. Let's see. We go 5 meters at 36.9 degrees north of east, because you start at the east and go to the north of it. And then we have, let's see, 9.05 meters at 6.34 degrees north of east. Start on the east, go to the north. To get x and y, we need to use SOHCAHTOA. So I want you to pause the recording for a few seconds, calculate those 4 values, and then we'll put them up on the board here so you can see them. Alright, so hopefully you paused it and you are waiting for some answers here. When I calculated them, I got, for down here on the XY, I got 3.99 blah 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 4, and I got 3.00 blah blah, doesn't matter, 3 meters. And then Bob out of the way a little bit. Yeah, I know there's something in there, but Bob's in the way. Then this one came out to 8.999 yada yada 9 meters, and then this one came out to 0.999, so 1 meter. So once we have those pieces of information gathered, our next step is to make one triangle out of it. One nice right triangle using the XY axis. So I'm going to move this vector down, and that's 9 meters down. I'm going to move this vector over. Notice how I'm moving my vectors. I'm not changing them, I'm just moving them. That's our rule. We're allowed to move them, we're not allowed to change them. Then you're going to use Pythagorean theorem to calculate the overall value. So you're going to say 14 and 9 on the x-axis is 13. 3 and 1 on the y-axis is 4. So a square with, or a triangle with 13 and 4 as the two things for the Pythagorean theorem. And you say 13 squared plus 4 squared. And my calculator went to sleep on me. It either said 158 or 185. I can't remember which. But then you square root it, and you get 13.06. So, in review, for all of these problems, write down the individual vectors individually. treat each one individually if it's not already on the x and y axis. If it's already a north-south, east-west vector, if it's already an up-down, left-right vector, then it's easy to work with. You can save that for the last step. But if it's at an angle, break it down into x's and y's. Then, once you've broken down all your angles into x's and y's, then you take all of the x's and y's and make a triangle out of it. That is your method. You're going to use that method on page 92. It's just practice problems. I think there must be section review problems there too. Practice problems, 1 through 4. That's what you do. Good luck.